Hi, hello, good evening. This is about the engineering project. Engineering is DE6102. Um, so this is student flat bush subdivision. It is about this is 5% work that need to be submitted. Okay, on the initially was 15th of August 2021. So now I think I have extended to 17 August. Okay, so next Tuesday there's the due date. In this site study, we're going to you're going to look at the this four aspect of this project. Okay, so this just this site study or site investigation form forms only 5% of the total marks. There will be other marks as well. For example, the concept design, the group work, and then the self reflections, and then presentations. And the bulk of the marks will be the final project. Okay, so this is just a 5%. But in this 5% site study, we're going to look at the four aspects. So the first one, it will be about the to how do we need to determine the proposed platform level, okay, from A to G. So I just so this is um, the Autocad drawing. There are for this site 221. Okay, there are platform A B C D E F G. So you need to determine what are the the platform level based on um, two aspects. So one is the contour. You see all the contour, um, and also the silver lines. Okay, so because um, the silver line is which is the this 375 PE, which is the polyethylene. Okay, so this the 375, and then go down this way from top to bottom. Okay, so we the wastewater will need to be discharged into this line via the manhole. I think we mostly this by manhole. Okay, there are some other sewer line here, but I think it's too small. Okay, so they got a 150 UPVC pipes. That is too small. So the wastewater in this parcel of land, uh, which has a total of 27 lots, they need to be discharged into the um, this manhole. Okay. The second part is we need to look at the hand auger, the soil condition of this parcel of land. Okay, so um, so I so we actually we don't have the actual the the hand auger result or the borehole results for this 221, but I make use of the neighboring parcel of land, and I adopt it to this parcel 221. So I assume the three boreholes result that need to be studied. So um, so this borehole results will be the hand auger result will be HA1, HA2, HA3. You need to study. You need to give some explanation. What is the effect of this hand auger results? Okay, so so you need to discuss the soil condition at the site 221 based on this Hanover result 1, 2, 3. Okay, and what type of subgrade of pavement will it be, and it needs to strengthen it. Okay. Okay. Thirdly, we need to look at the, the areas of this of this parcel 221, and to identify any place that that's quite steep, the slope is quite steep, that you they may need to have some retaining wall. Okay, so you need to actually you need to finish the platform level, then you can see the drop in the level, okay, from one platform to another, and from the actually at the boundary, okay, the boundary. So you can see whether any platform that you need to any place that you need to include some retaining wall. For example, this one, you look at the contour. For example, this platform D here. So this is about if you look at the contour, is about, it ranges from 44.5 to 46.5. So this place is about 44.5 to 46.5. So if you get it down to, let's say, 46, 46, or 40, let's say 46, then this one will be 47. So this is a drop 1 meter. Okay, so probably 1 meter is not that bad. But if let's say we want to drop it to 45, because we still need to, after we determine the platform level between uh, C and D, we might want to drop it down, because otherwise, if we have this one is too different, then there'll be a retaining wall at at the um, at the front here rather than at the back. If this is, for example, if this platform D is 46, and then this one is 43, this is 43, then there'll be drop of platform level from D to C of 3 meter. Then we need to introduce some platform, the retaining wall. But if you drop it down, for example, to 45, and then that one is, let's say, 43, okay, we might get away with the no retaining wall at front here, but we could put a retaining wall at the back. This one is 45. Let's say there's the whole platform is 45, and here is that this part is 47. Then the drop of 2 meter, we might need to introduce some um, retaining wall at the top here. And similarly, this part is a depression or valley here, 40.5. And then if we have platform level here, for example, is 42.5, 43. If 43, we will maintain 43. Then this part here, 43, there'll be a drop of about 3 meter. So we might need to introduce some a retaining wall, for example, here along this, this one, maybe along, let's say, here. Okay, so at the edge of platform B, with the valley or depression. Okay, so yeah, so that's um, that is we need to identify the area that we need to provide some retaining wall. Okay, let's see. And for D, we need to find out wastewater pipe. We need to determine the wastewater pipes serve all the lots, this discharge point. Okay, so if possible, we need to. I think at this point we're not going to do a details um, detailed design of the water pipe. The uh, what I mean by detail means that to identify the invert level of the various position, um, the depth of the or the invert level of the retaining the wastewater pipe or just the sewer line along the along all the various point. But we just um, to make sure that the actually the important thing is that the this sewer line will um, it may affect the platform level. So actually for this one actually we need to um, I think we need to find the invert level of the a certain point, okay, that may affect the platform level. So I think we just um, for this part we need to find out um, the platform level, the sewer line. Okay, so from this point and to what's the what's the depth of it, because we have the minimum depth of the sewer line. Okay, that is about, I think is the cover from the top need to be at least 0.9 meter. I show you. Um, so this one, let me see the under this certification. No, under page. Not this one. New settler print sample. Not this one. Cross reference step. Need to look at the PowerPoint. Image useful resources. Yeah, I think this one. Okay, so this is an extract of the um, this from the Auckland Court of Practice for Land Development and Subdivision, and this is the Chapter 5 Wastewater. So you need to look at this point, probably just look at this extract. That later on when you do the preliminary design, you probably need to look at the whole this the whole chapter of this wastewater, chapter 5. So um, the this the brown color is the wastewater. So actually it need to be like below at least 0.9 meter below the top of the rod. So we want to check the critical place, make sure that we have this 0.9 meter cover for all the rods. Okay, so um, so actually I did do some the 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 wastewater pipe. Later on that we need to, I think I will demonstrate how to draw this to determine the wastewater pipe later on. So we need to roughly sketch the layout of the wastewater pipe. This in the magenta color. So we 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 work we let's say if we determine to discharge this into this manhole, then we need to just to draw the line. This is just I think the preliminary line. We need to, I think, to fine tune it later on during the preliminary design. Okay, so just briefly, uh, this exercise mainly to make sure that the platform level is sufficient to have sufficient cover for the for this the sewer line, the sewer line, because um, the sewer line is critical because it has a very um, the drop in the slope is quite steep. The is about one in um, 1.2%. Okay, so the drop of the sewer line. Let's say we use the N150 150 for property connection. So the minimum grade need to be 1.2%. Okay, 1.2%, which is let me see, I just draw it out something. 1.2%, 1.2%, which is the 1.2%. So this, if this is 1, and what is the horizontal? Okay, so actually this one will be let's say x will be equal to 100 divided by 1.2, which should give us about 83.3. So x, so this is 83.3. So this is a slope. Okay, so that means that the slope, the sewer line, the slope is 1 to 83.3. So one vertical and the horizontal is 83.3. So it's quite steep. This compare it, because the other line later on that we need to determine is the stormwater pipe. The stormwater pipe is the drop in slope is much smaller. So I think we can compare to the sewer line, the stormwater pipe we can go to about 1 in 300. The drop. That means that um, one vertical and 300 horizontal. Then that is a much smaller drop compared to this sewer line, which is at least it must be 1 in, this one is at least 1 in one horizontal, sorry, one vertical and 83.3 horizontal, which the drop is quite um, is quite big. Okay, the we no need to worry about the water supply. That means that the water from this the water supply from the water care, this one the water will be tapped from this 250 this one PE, okay, polyethylene, the water pipe. You tap, we need to tap it, and then the water will go into the each lot, okay, to the house, to your tap, and because the water, it will, um, we don't worry about the gradient. It can just at a certain depth below the rod, um, which is the water pipe, the water, this color, the blue. It just need to be like 0.6 meter below the ground. That's all. Even there's a slope, the water still can go up because it's on the pressure. It's flowed by gravity. There's a water tank somewhere which provide enough pressure that even the water can go up against the slope. It only become critical when there's a high rise. The water will not be able to reach the higher stories. So that one probably you need to have some water pump to pump the water up the higher building. Okay. Yeah, so the intention of this to find the wastewater pipe, the 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 depth of the invert level, or which actually mean the cover, which we want to determine if the cover is enough. Okay, which is critical um, at this platform A. Platform A will be much lower because of contour. This place is lower compared to platform D. D is probably the highest, and then stopping down. So, but um, the wastewater pipe or the sewer line, it will be the similar depth, compared to the distance from this point, for example, from this point. So this one will be, if you want to go down all this sewer line from here, definitely the cover here it will be um, deeper. It will be sufficient because the existing ground is higher compared to this one. Because the existing ground, even the platform will be lower. So this is the critical point here. Okay, or even here. So yeah, so let's explain how we're going to find uh, we need to do the wastewater pipe. We need to find out the platform level. We need to find out the invert level at the furthest point to make sure that all the platform level that we have determined they can provide sufficient depth to um, the sewer pipe. Yeah. Okay. So I think I just roughly look at the um, let's see. Um, I think I roughly look at the contour. Okay. So I look at this. Okay, I have this image put on the words. So um, so I think let me see. I just draw something. Um, okay, I think this one I can see from here, but um, contour. Okay, let me see so this one will be 40. Um, this contour will be 47 because it's the difference in the contour level. The interval of contour level is zero point 0.5. So this is 47, 46.5. This 46, 45.5, 45, and then 44.5, and then this is 44. Okay, so roughly I just draw something. Let me see. I just put a blue line. This is 47, 46.5, 46, 45.5. This 45, 44.5, and this one will be 40. This one will be 44, 43, and this one will be we have 42.5 here, and then 43. Yeah, this one is 43.5, not 40. Okay, and we go down that way. This one will be 42.5 because continuation of this contour. 43, and then this one will be 42. So going down further down, this one is 42. This one will be 41.5, isn't it? This is 42.5. Okay. So So this platform E here as well, the 42.5, this 43, and this is a small hill here. Okay, so the same thing, we can do the same thing for this platform F and G. So looking at that, the platform level, we look um, like 47, 46. So this one at the middle here, probably about, this one is 45.5. Yeah, so this one is 47, 45.5. And then this one is going to be, let's say, 43 or 44, this top here. It could be, let's say it could be like, PPL, proposed platform level. It could be 40, let's say 43.5. We could use that. If we maintain the difference between these two, we could use 45.5 or 45. Okay, let's say it could be, this proposed platform level. It could be 45. So that means that this drop, this one is 47. So there's a drop of 2 from here. And then that one could be, drop from D to C is 1.5. This one is about platform B, around 42, 42.5. 42 is a bit too low. So let's say 42.5, the PPL. And then further down, this one could be near similar to the rod level. Okay, the rod is about 42. 42. I think that one probably about similar 42. So it could be just drop of it could be PPL equal 42. Okay, so this just the same, this platform level, and we have this place here, this contour here is about 40.5. So the depth of the valley at the bottom is probably 40.5. So we're looking at about 2 meter drop, between these two. Here the valley and here, and then you look at the closeness of the contour. That means that there's quite a sharp drop of, of this platform to the bottom. Okay, so this how we determine the platform level. Determine the platform level. So okay, so this is based on the contour. Later on, we need to actually we need to finalize. We need to check with the wastewater pipe, see whether the depth of um, the depth of the pipes, the depth of this pipe, the wastewater pipe at this point or this point, the critical form, whether this pipe has enough cover from the rod. Okay, if we put the pipes below the rod, so we have probably because the platform is flat, so the rod will be flat as well at this point. Okay, only the rod could it will be flat between the platform. Okay, so because the platform, this part, the rod is level, but for this rod here, the from here, I think this rod is called rod A. I think it's it's rod 1. Sorry, rod 1. This rod, it will not be flat, it will not be level, because the platform is increasing. I think the platform E, F, G, they'll be increasing as well. So the rod actually will increase in height. So there be it will sort of the rod will increase in the rod level will increase, okay, from this point here, and then it will increase until the end here, okay, until this point here. So there'll be later on you need to show it um, at the long section when we do the rods, um, we're not doing this for this site study, but later on in the preliminary design we do the long section of the various rods in the cross section. You need to show that there's an increase in gradients for this rod C shown in the rods in the long section. Okay, so that's about the platform level. How you do it by how you determine by the contour. The third condition, I think you just look at the hand auger result. Okay, so the head HA1, we have HA1, and then we have HA2, and then we have HA3. I think you need to look at what will it mean, will certain part, HA1, it will be at the around platform A. I think the bottom one, HA1 is at the near to the rod, and HA3 will be inside, near to the back. So the HA1, this one, the existing ground probably about at this point is about 40. Where is it? Let me see. I just look at the word. Let's say the this part here is between 42 to 42.5. So there's a minimum cut here, and then HA2, this part will be about let me see, probably between 42 and 42.5, 42 to 42.5, and the rod here probably is going to be 40, somewhere in between 42.5 and 43. So it's probably the rod the top part of the rod probably is not very deep. Okay, the cut probably not very deep. Okay, but this one probably is deeper. 40. This is 45. This place is about 45.5. Probably not deep as well. If it's, let's say we use PPL to 45, probably it's quite close to the quite near to this HA3 is the top is quite near to the platform level as well. Okay. So you look at that means that the top part will be quite near to the like 0.51 meter, which is clay silt. This HA1, and HA2 is the top part. Probably it will be 0.51 is also the clay silt. Okay, and the one at the back also about silty clay. So silty clay. So um so 0.5. We know that I think the clay probably is not a good soil for the subgrade of the rod. We study in like highway 1, because the clay, it can swell when it's wet, and it can shrink when it's dry. So comparatively, this soil here, let's say and this quite a lot of silty clay, compared to the ones clay silt, or this HA2, or the HA1, let's say it's bordering the silty clay at 1 meter plus as well. So this one is the clay silt probably is not bad because like is I think it's almost cohesionless soil. Yeah, of course it's not as cohesionless as a sand, but it doesn't exhibit the this one the volume instability of the clay. Okay, so this one is probably it has more volume stability, the silty clay. So you can look at that, the subgrade at this various position of HA1, HA2, and then you can make out what sort of subgrade it will be at this various position. Okay, you can determine that. So the area of steep slope, just now I think I talked about that, the steep slope. For this, because of the because of the change drop in um, drop in the level. So this part probably, yeah, this part, the maybe we need something, because it could be, let's say, depending on the drop, what is your platform level? We could be here, or could be, or we could be, the here. So they determine based on your platform level. If you have 46 and then 43.5, probably you might need to do retaining wall down here because it's the drop. The rod probably, this that actually called the what's it called? This is the JOAL, which is a joint owner joint owners allocated lots. So this one probably it could be, let's say, if this platform it is different, it could be somewhere in between. Okay, you could have this called a JOL1. You could have it follow the platform of the C, the so, and then this one your driveway, you from this JOL1, it will the driveway to enter this various lot, you will climbing up, it's going up. So if depending on the platform level of this one and that one, you could be having let's say, because a drop in height, it could be here, the retaining wall, or it could be there. And this one, because of drop here, you may need to have something here as well, retaining wall. Okay, depending. Okay, the retaining will start here, something like this, from the origin. The ground is this part probably about 42, 41.5, and then this one is so it need to be vertical wall. Okay, so that we cannot have this natural slope because it's quite steep, so we need to have vertical retaining wall. Okay, so that's about the retaining wall. This one here, there's a hue. Probably you're going to cut off everything, the hue here. There's the whole thing just cut off. Okay, so you can think about that over here as well. What is the whether we need any retaining wall here as well, based on your platform level. Okay. So the last one we need to look at is the the probable water, the wastewater pipe, or the sewer line. Okay, so the synonymous synonymous. Okay, so this it could be the sewer pipe. Oops, to erase this. So this wastewater pipe, or just the sewer pipe. So that's a similar thing. Okay. So what we can do is that, we can find the manhole level. What is the we just draw a line first. Okay, so um, I will create a layer, a new layer. I will do the I think that I just do the just type project because I want everything under the project to be in the group similarly in the same place. So that I other project, I just say project just put sewer line, project sewer line. I give it color. I think I put the magenta, and I want to give it some light weight as well. I think I just put it to, let's say 0.3 mm. So I made this current. Okay, so I just use a P line, PL, and just roughly. So this line I just so there'll be a line here, and another one, let's say from here, somewhere along, it could be below the rods. So I just near NEA at the point parallel. We put the sewer line parallel to the rod. Okay, and so this line will serve the platform A, the lots in platform A, and then I need to put a line here as well. It will serve the lots in platform B and C. So over here, I parallel to the rods. Just do a near. Okay, and then I need to have another silver line as well. I'll just put a P line, PL, probably this side. Just near. Just actually you need to do. I think the just parallel to the rod. Okay, and all this the sewer line, they will need to, I think this is a good place to drop in. We got a manhole up here. The sewer line, this 375 PE, the polyethylene, is going to flow this direction, and then there's the manhole here as well. I think this is a good place to put because nearest. So I will put it, let's say near NEA, near. I just join this place intersect. Okay, so this roughly is the the layout of the sewer pipe. I just copy this. We need to manhole. The manhole size need to be determined later on as well. Just copy. Okay, probably I just here. So we put a need to put a manhole here. Just put the middle. Okay, so here, manhole here, and then when the pipe join together, this pipe, the junction, we need to put a manhole there as well. The end, you don't need to put a manhole because they just put an end cap, and here as well, the end cap. We need to put a manhole here as well. Okay, so now we need to determine the depth of this. How is the invert level of this? Okay, let's say we look at here. Okay, I just zoom out a bit. Okay, choose this manhole here. I just put in green color. This is the 4.9. So actually, this is the it's 4.93. 4.93 here. So this is the depth of the manhole. Okay, so this is the existing ground level, which is at this point is about between 43 and 42.5, which is about, let's say, 42.8 meter. If this is 42.8, then the invert level, it will be equal to 42.8, isn't it? Minus 4.93. That will about I think it's 37.87, isn't it? It's 7 meter. Okay, yeah, 37.87. So that's the invert level of this point here. Where is that? The invert level of this point for this 37.87. Okay, if I put that value into the AutoCAD. Yeah, let's copy this value here. Let's turn this off. I rotate it to the horizontal. Okay, I can write. I can do m text, but I just do it. Make it smaller. I don't need this big. So probably get it to 2. 2.0. Okay, make it smaller. Yes, size smaller. So this one will be IL equal to, just now we put in, which is 37.87 meter. You want to do that. Okay. So that's the invert level, and we need to find out the different level. I just copy the point here, this point, this point, and probably this point, already. Okay, what's the invert level? And that one, yeah, we put because these are the critical point. But comparatively, because this one is further, so the drop could will be bigger. So this one probably is not so critical. So we just need to determine what is the invert level here. Okay, so we need to find out just now we said that the drop, the slope. I just put just copy this. I just put a mtext, mtext. Okay, just put it a 2 meter drop. Sorry, not drop. Text. Just put it to the area. What is that? Area. Okay. Slope. Sewer by is 1 in 83.3 meter, isn't it? Yeah. Yeah, where is that? Yeah. So this is the guideline. So we need to find the so from this gradient we can find what is the invert level at this various point. So I just find the distance. Just put this one from here to here. At this point. Which is 49.61, 49.62 meter. Okay. 49.62. So what should be the drop? Okay, let's copy. Let's do. So the drop is isn't it? The drop equal to just now that one is 49. I think it's 49.62, isn't it? 49.62 divided by 83.3, which equal to, what is it equal to? 49.62 divided by 83.3, which is 0.660 meter. Okay, so the drop is for this one is 0.6, so there is 0.6 meter. So I can say that this one, the invert level will be 37.87 plus 0.6, 38.4, so 38.47 meter. Okay, so this invert here, and then we go up. We want to find out what is this point here. Okay, because we need to find here the invert level here, so we need to find what is this point here, because it's all joined, assuming that we maintain, let's say, that the slope of the slope, we mean at least, because we need the minimum slope is 1 in 83.3. So we need to find the distance from this point to this point here. So what is the distance? 46.97, 46 point, let's say 46.98. So the drop for that point is when so it'll be 46.98, isn't it? And then what should it equal to? 46.98 divided by 83.3, 0.56. So 0.56. Okay. So that means that this platform, the invert level at this point, just move it a bit here. So I have to be 38.47 plus 0.56. 38.47 plus 0.56, 39.03. So this one will be 39.03 meter. Okay. And okay, so I just after this I just take away that one and want to find out what's the drop for the final point from this point here to that point the end. We need to find the distance, so and then we can divide by the slope, the vertical, the horizontal slope, then we can find what's the drop. So we find the diameter from the end here. Let's say just to the edge of the manhole, which is 81.25. 81.25. So 81.25. Just move it around. 81.25 divided by 83.3. What do you give us? 81.25 divided by 83.3 divided by 0.975. Let's say 0.98. 0.98. So there's a drop of 0.98. So what will this be? So oh, this one is not 339, 39. Okay, 39. 39.93. So the one here, the 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 invert level here is it will be 39.03 plus 0.98, 40.1. So 40.01, actually 0.01 meter. Yep. Okay. So this is 40.01 meter. So this is the furthest point, So we need to have the cover of 0.9 for the sewer line. So this place at least need to be 40.9. The platform here needs to be at least 40.9, or the rod rather, it needs to be at least 40.9. So to provide sufficient cover for this sewer line. So we look at the things here. Let's say we looks like the just now the lines here. This one probably about 42.5. This 42. So it's much bigger than 40.9. So the sewer line, the depth of the sewer line the invert level of sewer line doesn't affect the platform level that much. So actually, the platform based on the contour they are quite I think will be quite probable. So it's not affected too much by the sewer line. It it can be a problem, let's say, because the platform is so long, for example here, because of contour, it could be here is 38, something like that, 38. Then if you do this thing, the sewer line going back, and then we need the sewer line, we need 40.9, but this one's 38, then we got problem. So in that case, we either we could the sewer line, it could discharge to the other manhole, which is deeper, or we need to rest up the platform. Okay, so to at least like 40.9, from so that we need to top up the level, we need to fill so that they can provide sufficient cover for the sewer line. Okay, yeah. So there's so much about the 4 parts of this site study. So yeah, so I hope you can give you a good insight of what you can do for this site study of this parcel of land at 221. Yeah, so I think I will stop here now. Okay, uh, hopefully you can do a good job for this 5% site study. Okay.